Good morning. Hope you are staying warm and enjoying your time off. We are going to be taking a look at 6.1 today. Now, this sheet is available on the file cabinets at the bottom of the assignment link that I sent out. You're able to download it. Also, first and third period, if you have your math notes where we took notes on writing inequality or equation, deciphering if word problems were inequality or equations and writing those, it's on the back of that. So you have a few different places you can find it. Now what we're looking at today is converting a fraction to a decimal. So that's what we're going to be doing the entire time. Now first thing you'll notice there's an equivalent reference sheet. This should look familiar. And unit 1 of this term we took a look at decimals to fractions. So we converted decimals to fractions. Just as a brief reminder on that, so if you had the decimal like 0.5, we can take a look at that as 0.5. 5 is in the tenths place, so we place 5 over 10, and that simplifies down to 1/2. Today we're going from the fraction to the decimal part. Now, one thing I want to point out with this equivalent reference, these are common decimals to fractions, fractions to decimals that you do need to know. So these are ones you're going to realize you're a little bit more familiar with them at this point since we went the other way around the last time. So make sure you know these fractions to decimals equivalent very quickly. These are going to come up a whole lot in your future mathematics courses, and they're going to be important ones to know. So this is your reference sheet for that, and we'll be going over them sort of as well. Alright, so let's take a look at some where we may not know it exactly automatically. Alright, so write each fraction as a decimal, use a bar to show a repeating decimal. Alright, so take a look at this first one, 4/5. Now this is one I expect you to know automatically. Let's say you didn't know what that was. And the way to convert a fraction to a decimal is set up, well, there are a few different methods, but the way we're going to take a look at is setting it up as a division problem. So you'll set up a division problem. Your denominator will go on the outside, your numerator will go on the inside. Now you're going to want to add some trailing zeros here. Place a dot over there, because 4/5 is the same thing as saying 4 divided by 5. So we're dividing 4 by 5, so we're finding their quotient. 5 doesn't go into 4. 5 does, however, go into 40 8 times, and it goes in there cleanly. So 4/5 equals 0.8. One thing, I do want us to start putting the 0 on the outside of that. So we're going to do the same process for these. Get to know it does that. Alright. That's one. Alright. So number 2, we get -1/9. So here we're dividing 1 by 9. Now we know automatically this is going to be a negative decimal. So we're good to go there. Another thing we also know, since the numerator is smaller than the denominator, this decimal is going to be less than, well, 0, but the absolute value of it's going to be less than 1. So we automatically know it's going to be 0 something. Set that up. And we can ignore the negative sign. We're not ignoring it per se, but we're just signifying it in that final answer. Put some trailing zeros. 9 on the outside. Match up the decimal spots. 9 doesn't go into 1, but 9 does go into 10 one time. Remainder of 1. Bring down that 0. 9 goes into 10 once. 10 minus 9 is 1. Bring down the 0. 9 goes into 10 once. And you'll notice as we keep on doing this, we get 1s repeating. So that's what the directions are saying. Use a bar to show a repeating decimal. So we can just write this as negative 0.1 with a bar just over the 1. Now you also could write this as negative 0.11 with a bar over both of them, but the simplest way is just to write it with the first repeating digit or expression if there are multiple ones. Now one way you can always check these is to bring up a calculator. So keep in mind it's the numerator, so you can say negative 1 divided by, oh no, not that. Let's clear that up. 1 divided by 9. 0 point, you'll notice the 1 are repeating, so you can use a calculator to check these. So if we want to check number 1, we have 4 divided by 5, it's 0.8, so that works out. So that's a method you can always do to check, and I'm finding for using that to check. Not to do the work, but to check it. That's completely fine. Alright, let's take a look at number 3. I'm afraid you won't be able to see this. Alright, so 3, we have a mixed number of 4 and 1/5. So we automatically know that decimal is going to be 4 point something. Now 1/5 is one of them I want you to know automatically, but let's say you just forgot it. That's fine, but this one's nice. 5 goes into 1 0 times, 5 goes into 10 2 times, and we won't go in there evenly, so there's no remainder. So 1/5 is 0.2. So 4 1/5 is going to be 4.2. And if we bring back up the calculator, keep in mind it's that whole number, so 4 plus the fraction part. So it is 4.2. So that's something you can always do with those. Alright. So 4, we have 8/9. Once again, since that numerator is smaller than that denominator, we know it's going to be 0 point something. Set up our numerator, some trailing zeros, divided by our denominator. 9 goes into 8 times, since 9 times 9 is 81. So let's subtract 72. Remainder of 8, bring down the 0. 9 goes into 80 8 times. So you automatically sort of know, oh wait, we tend to get a lot of 8s here. And that's going to repeat 8, 8, 8. So 8/9 equals 0.8 repeating. That's our final answer. Keep in mind we have an equal sign in between these. Once again, this is showing that 8/9 is equal to 0.8 repeating. So we do need to be careful with that notation. Once again, we can check that. 8 divided by 9 keeps on going. Now you'll notice at the end of this calculator here, it has a 9. That's because it rounded it. So it rounded 0.888. Once it fell out there, your calculator will end at a certain point and then it will round. So since the next digit was 8, it's in between 5 and 9, that 8 was rounded up to 9. But we want to express repeating fractions with bars over them. But just keep that in mind, that is a strategy you are going to see. Alright, next one we're going to take a look at is number 5. Right, number 5, we know we have negative 6 point something, but one thing I want to point out here, 5 over 20 isn't completely simplified. So if you notice something isn't completely simplified, go ahead and simplify it. It may make your life a little bit easier. So let's set this up. It's negative 6. So we can divide 5 and 20 both by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. Now 1/4 is a fraction to decimal I want you to know. So 1/4 is 0.25. So this is going to be negative 6.25. So keep in mind, make sure you simplify any fraction bit, because it may be one you automatically know. So be careful with those. And once again, you can always check these with your calculator. And I'm going to recommend you do that, especially since the sheet, I will be checking it the next time I see you in class. Alright, so for the rest of your homework, I want you to do 6 through, yeah, 6 through 12. So I'll state the rest of those, fraction to decimals. Next thing we're going to take a look at is using comparisons. So we're asked to write greater than, less than, or equal to in each blank to make a true sentence. So here we have a mixture of fractions, we have a mixture of fractions and decimals, so we have to level the playing field here. Now since we've been converting fractions to decimals, we're going to convert the fractions to decimals to compare. So 19, we have 4.79, and then we have the fraction 4 and 1/8. Now 1/8 is a fraction I do want you to know, and that fraction is 1.25. So 4 1/8 we can take a look at as 4.125. Now it's going to be helpful to have both rational numbers expressed in the same form, whether it be both fractions or both decimals, because it's going to be a little easier to compare. So we start from left to right, compare. All right, 4 is the same, so the ones place is the same. The tenths place, we have 7 and 1. So since 7 is greater than 1, 4.79 is greater than 4 and 1/8. So that's what we're looking at with those. Alright, now let's take a look at 25. Here we have two fractions. There are a few approaches you can take here. One approach you can take is you can compare them when they have the same denominator. So I'm going to rewrite both fractions so that they have the same denominator. Our least common denominator in 25 is 9. 4 9 already has a denominator of 9. I need to multiply 2/3 by 3 over 3, so that will become 6 9ths. Then we have 4 9ths. So when you have the same denominator, whichever numerator is larger is going to be the larger one. So since 6 is larger than 4, 6 9ths, or in essence 2/3, is larger than 4 9ths. That's a strategy you can use on those. Another strategy would be to convert the fractions to decimals. So that you have a preference there. We also could have converted 4.79 into a fraction as well. So you have a few different options here as well. Alright, for the rest of your homework, I do want you to fill in each blank to make a true sentence. So once again, you can print this out. If you want to complete it on OneNote, you can, but I will be checking it the next time we see each other in class. Alright, stay warm.